My name's Chris Tite. I'm a director at Code, and I think being a director gives me two great opportunities. One is that I get to carry on coding. I get to tell people that I carry on coding. I don't want to just run a company. And the other one is that my company is generous enough to give me the opportunity to get time out to talk about the stuff that I code. So this is me sharing with you what we actually do. I had some feedback from this talk at DevConf with some great feedback. And some of the feedback was I talked too fast. So this is a half-hour talk, and I did talk a little bit fast. So I'm going to try and stretch it out a little bit, and it might go slightly over. The other thing is that if I talk too fast, I'm thinking maybe we need a safety word. Like, it's too fast. Like, slow down. All right, I don't know, like flugelhorn or something like that. I don't know. All right, cool. So before I start talking about my architectures, I want to share with you this building. It's called the Interlace, and it's designed by a gentleman by the name of Ole Schroner. It's German, I think. But there's some amazing things about this building. He's used a cantilever design, as you can see here, and he's actually designed the building to increase privacy by placing the building at different angles so that people aren't looking into each other's apartments, but to increase space for community living at the bottom. Some really interesting balance. The other interesting thing that he's done is when you look at this from a computer model is that he's managed to create space. He's reclaimed 112% of the space that he used, the surface area that he used for that particular building. So this is quite an amazing achievement. When I look at this building, I have two words: balance and elegance. And some people find this building a little bit jarring and tend to find this a little bit more aesthetically pleasing. This is a building called Falling Water. It's one of my favorite architectural buildings. It's designed by one of my favorite architects, which is Frank Lloyd Wright. And the interesting thing is that this building was designed and built in the 1930s. And the thing that these two architects share is that they studied architectures. In fact, Schroner probably studied Lloyd Wright's architectures and probably got a lot of ideas from the architectures. And that's the thing that makes me quite interested in sharing architectures, because as software developers, we don't get to look at a lot of architectures. We either get it by banging our heads or working under a great architect or potentially reading some books. But as we grow, it's very difficult for us to get out there and actually get the content. And so the idea that I struck upon once was to say, well, how about I just share what I've done? How about I just start talking about my architectures, be they good or bad, and just share with the pain and the joy that we've actually experienced. So normally I talk and I hand out beers, and this afternoon I was going through my slides and I hit this slide and I went, oh crap, I forgot the beers. And Stephen's going to say to me, dude, you've done it again, because on the last talk that you did in the company, you forgot the beers, and I've forgotten the beers again. I'm sorry, guys. Probably next time. All right, and that's the first talk, and I hope the last talk that we don't actually do the beer fiasco again. All right, so in order to do an architectural discussion, I actually need to give you a point of reference. I need to be able to tell you what the problem is we were trying to solve. Need to be able to show it to you and say, this is what we were trying to solve, and this is where we actually took the solution. I have a client. I'm going to call him Hell, H-A-L, not H-E-L-L. Hell has access to a large amount of data about you and I. It's actually a scary amount of data about people like you and I. And what he has as well is a customer. And this customer has some things called employees. I don't know, you must know about these things. And they have family. And these customers also have suppliers, and they have directors. And what Hell's solution is to try and divide this system in half and try and find links between these people and these people so that he can try and detect fraudulent behavior, nepotism, and the like. All right, so this is the connectivity problem, where we're trying to see who here is connected here via all kinds of interesting ways. Did you sell a property? Did you buy a property? Have you done any weird financial transactions with this particular person? Are you in business with this particular person? Any way that any kind of data that they have, they would try and make connections and try and find ways in which people are doing potentially fraudulent behavior. Hal phones me up one day, as is normally the case, and says, Chris, I have this problem. I've landed this new client. I have 70,000 employees inside the system. I have 30,000 service providers for this one particular client, and each service provider on average has 5 directors. And he says, the calculations at the speed of the system that we're currently working on, it's going to take us 3.5 months just to process all of this stuff. And I've promised them that they'll get a report every month to find fraudulent behavior. So we have a potentially massive problem on our hands. And Hal's just made his problem my problem. All right. So the first thing we're going to do is go into the system and have a look and see why is Hal's system causing such problems. So let's take a look inside. So we talk about the system at the moment currently processing 25 individuals in 15 minutes, and it's going to take in excess of 3 months to be able to do this massively large amount of data. And if you look at that, 25 individuals in 15 minutes is shockingly slow. It's just not performant at all. We look at the solution. We have a web-based front end. We have a database back end with 2 databases. This is all a relational database. Everything's in SQL. Everything's nicely branded. It's all Microsoft technology. And the interesting thing is that the previous developer had decided that he was going to use Microsoft SQL Server Integration Services, currently known as SSIS, to do all the coordination and all the collection of this data, including connecting to a web service out in the ether to pull down web data from one of their data suppliers. And Hal had been advised that he must reach for this amazing tool called BizTalk Server, the classic hub and spoke centralized SOA solution. And he was nauseated, to say the least, by the price tag and the fact that he would have to ship some consultants in to solve this particular problem, and hence the call. One of the things that frustrates me about this particular architecture, because it's not the first time that I've seen it, it's not the last time I'm going to see it when I walk into a potential client, is that a developer had one tool in mind. He knew how to write sys stuff, and that's the only tool that he used. It's the completely wrong tool. It's that same, I have a hammer, I'm just going to use this. Everything looks like a flippin' nail to me. What happens with this integration system is it falls over regularly, and then they'd have to restart it. It is super memory hungry, and it's absolutely dog slow to process. Besides processing internal, it's also got to do these calls out to the ether to be able to get this data. One thing that also frustrates me about this is that they were blatantly blinded by one technology service provider. And I don't actually want to just single out Microsoft here. I see it with Oracle. We see it with SAP. You see people just, there is one solution that we have here. We must use that one solution to solve every single problem that we've got here. In this problem, you'll notice later on in a couple of slides, is that this is a highly connected data set. We're actually needing graph database technology. Microsoft doesn't have graph database technology, but we're lucky enough to consider it open source solutions and find that there's open source technology out there that can solve this for us. So consider open source. And while you're at considering open source, there's this amazing, amazing tooling called Docker. And if you haven't used it, I'd suggest you go out there, because it's turned my life around in terms of getting access to new tools and new tooling in that open source space. We also need to consider the data. It's highly connected, and therefore probably not a relational database solution. And it's also coming on from multiple sources. So we've got sources from here and sources from here that we need to consider. And then a big question on this particular project was unit testing. How on earth, I mean, somebody please tell me this, especially from the Microsoft community, how on earth do you unit test that thing? Or that thing over there? And once you've got unit testing done, how do you do the performance testing? It's actually a very, very difficult problem to solve. All right, so that's our problem space. Particularly knotty, a central hub that's just processing everything in a central place, and everything's falling over. So what did we do? The first thing that we decided to do was introduce this service bus, or some sort of bus, or message bus, for robustness. And the idea behind the message bus is that something creates a message to tell a process on the end to do a particular action. I want you to perform a check on this particular person. It sends it down the message bus, and these get collected at the end point and just stored for when this processing element can pick them up, do the processing, take the result, and send it further down, either back to the result, either back up to the requester, or send it down via an event to a whole heap of other people that might be listening for that particular event. What we've now solved is that when the system of this point of view slows down, or when it falls over, the messages just back up until this is back on track again, and we now have a little bit more robustness built into our system, just by introducing this bus to what we're trying to solve. In the busing technology, we have this concept of commands. So a command is an endpoint saying, I want this particular endpoint over here to actually do something for me. And we have this idea of events where when an endpoint can actually broadcast, this is actually happening, and I can listen for these events and make a decision on what I've actually done, what I need to do. The other thing that what you start to reach for when you're doing this message bus is that we start moving more to a request-react type pattern, and we're a long way away from this request-response pattern, which starts creating a high coupling. Right, so request reaction gives us a bit more loose coupling, and this request response would give us this high coupling. And if you think about request response, it's the typical web service. Give me a request, I wait for some processing to happen, and then the result gets sent back again. That's where the high coupling starts coming in. So we're starting to move into some kind of reactive process or reactive system. The other thing that we introduced at this particular point is a service host pattern. So this point over here is a simple, lightweight element. It uses inversion of control to be able to inject what it's trying to inject the elements that it needs to be able to process. It's lightweight. It can stand alone on any service. It can be moved from one server to the other, can be pulled up and pulled down very, very quickly. Unlike the Microsoft Hub and Spoke, bespoke, centralized command and control system. This starts to give us infinite flexibility, and we'll start to see further on where the flexibility comes in. The other thing that we reach for is this transactional service pattern. So in these types of systems, you want to actually know that when something fails, the transactions that you've already started processing are going to roll back correctly. That includes sending events back up the bus. That includes writing information to the database. If you're not thinking very carefully about the transactional service pattern, you're going to have a whole heap of problems on your hands. Normally, people solve this by doing a compensating transaction. So I'll do this, I get this particular distance down the series of transactions, and then I'll have a compensation to roll this back, and they hand roll that. That you can do, it just becomes very, very tricky when you've got a whole heap of things that you're trying to do at exactly the same time. And what about testing? So in the previous talk, in the previous slide, I'm saying, hey, but you've got to be able to unit test. At this particular point, we've created a point of inflection right here where we can actually abstract it away from what we're actually doing and test this thing in isolation. We can test injecting, because we're using an inversion of control styled host, we can inject mocks, and we're able to start testing exactly what we're doing. All right, so now we need to, we've introduced this bus, and we've got to move on to trying to process this large amounts of data. And in a previous solution, I'd actually used this parallel pipes pattern, which if we look at this particular diagram, it shows you the parallel pipes pattern for a credit card vendor. What normally happens is that you need to be able to, at this particular end here, calling into the credit card system, you need to be able to process things exceptionally quickly. And most of the time, these items will become the bottleneck. So you don't actually want to run everything sort of in the same process. What you want to be able to do is call into this point, validate against a particular blacklist. So is this particular card on a blacklist? Once I've validated that I'm okay, pass it over to another service that will do some fraud detection. Is this outside the guy's buying patterns? Once you're happy with that, move it on to authorize it. Can we authorize the card? Go to the particular vendor or the particular bank and say, listen, we want to be able to authorize this transaction. Then settle the amount. And as you're going, you're taking the transaction and moving it on here and being ready for the very next transaction. So we're actually splitting this thing out into a series of parallel processes. And what we did was we actually turned it on its side and run the parallel processes this way. And instead of passing messages from one to the other, we just got this dispatcher to pass the messages down a series of pipes. And so we've now created these parallel pipes to start increasing the amount of processing that we can do. What we've started to apply, now we've alluded to it in the previous slides, is that we're starting to apply this reactive pattern. But essentially, this dispatcher putting a message on the bus, this particular point doing something, and then sending the result back up again to be processed at a later stage. So this is pretty much saying, I request this, and I'm waiting for a reaction from an endpoint. All right, and then we've got this decoupling that we're now able to introduce. We've introduced a dispatcher. And we started to introduce a shard point, in this particular case, the verification types, all the different types of validations that we have to do and all the different checks. We've now created the shard point inside our system, and we create a series of pipes for every single one of those shard points. At times, we also created shard points along the different types of people that we were busy working on. Is this a director? Well, then you go down this shard point. Is this an employee? You go down this shard point. Is this a company? Then you go down this shard point. So we're actually splitting the data out into many different parts. And the only way that we can do that is to have lightweight, usable host components that will be able to host this particular service. All right, so we also, when we were doing this, we also started to separate the response paths. What we found is that in the early days of testing, put the request on one bus and then send the response back on the same bus, just clogged everything back up again. So we created separate buses and just started to get the throughput through in that particular way. We also created this concept of a coordinator. So at this particular point here, we get the messages popping up from these endpoints, and the coordinator is taking the information, coordinating it, and then deciding what alerts they need to raise for that particular client, individual, or director.
Sorry, what's the difference between the dispatcher and the coordinator?
So the dispatcher basically decides where am I going to send the data out to, which endpoints do I need to send it out, what verification am I doing. So have I got a customer? Have I got a company? Companies have different checks to directors. So the dispatcher would then decide you're going down these queues, and for a director you're going out down that particular queue. That was just our neater way of actually breaking the process down into a slightly simpler set of endpoints that we could actually work against. So the coordinator is actually getting all the information back. So there's from these endpoints that are coming back from the processes that are popping back up again, and it's just saying, I have 10 messages that I'm expecting for a particular company. Using this coordination ID, collect all the information, check what alerts I need to raise on this particular behalf, and then raise the alerts and save the information away. So that's essentially what the coordinator was doing. Yeah.
So that coordinator, so would you say for some sort of process, essentially I've dispatched this information, it's gone down a number of those pipes, and in order for me to give alerts and responses and everything back, I need to have received these 10 responses. So you're saying the coordinator is almost going to wait for all of those responses to have come back before it actually sends
Yeah.
Is that,
In this particular
is that
case.
the kind of job it's,
Yes.
it's pulling them back together.
Yeah. That's right. So in this particular case, I mean, you could do this in a number of ways. In this particular case, we had to get a large amount of information back and say, at this point in time, this is what this person's profile looks like. So we couldn't send small bits of information across. We also had to do a delta from what he looked like previously to what he looks like now. So you had to create a profile and compare it to the previous profile, and then based on those two profiles, raise a series of events or alerts to say, this is out of kilter, or this is a problem, or this is an issue. And that's essentially what that coordinator is actually doing for us. All right? But the thrust of this is to say, we have a dispatcher that decides where it's going to send the information. We have a coordinator that pulls that information together and actually coordinates everything so that it knows what to do. There's a whole point of separation of concern. I'm only concerned with dispatching. I'm only concerned with dispatching. And these endpoints here are only concerned with what they're actually supposed to be doing. I need to do this type of validation. It's very, very specific and it's very clear. If you have a look at the code in these particular endpoints, it's not super complicated, it's not super long. I'd hesitate to say it's almost like a microservice, but it's not really. It's a micro piece of code that would do something very specific and very pointed. We noticed that we also, at this particular point, needed to sometimes connect to multiple data sources, and they were data sources specific around what this particular point was actually doing. And these data sources often were different types of data technology. So this data source may be a Neo4j database, and this data source over here may be SQL as well. So there was patterns where we needed to connect to different data sources, and that's really what I'm trying to highlight there. And one of the other patterns that we managed to implement was this distributor pattern for load balancing. So on certain checks, things take a lot longer. They're a lot more complicated. There's a lot more connectivity checks that you need to actually do. And you really often want to just push the information to an endpoint and allow that to farm the messages out to another process to be able to work on it. So we applied this entire solution using NServiceBus. What we've got to say is that the solution was applied probably 3 years ago. 2 years ago, 3 years ago now. And as we've evolved, I may not use NServiceBus on this particular solution, considering that we may go from some sort of event sourcing, and we're sitting at the moment playing with Akka to see what it would look like to have a completely reactive network using a sort of actor model to solve this particular problem. So we're busy playing with that. And those are other technologies that you could consider. Don't necessarily need to only consider NServiceBus. I think, no, product escapes me. Oh gosh. Oh, no. All right, so I might get slayed for this. One of the things that I'm quite adamant was, in this particular case, we weren't going to roll our own. In terms of host processes and managing all this stuff, we did use NServiceBus because we had to solve this particular problem exceptionally quickly. We didn't have much budget to move on. You can roll your own if you're in the habit of writing these types of tooling and you wanted more control. I just find that it sometimes just becomes a little bit more complex. I have a business problem to solve in this particular case. I'm not trying to solve plumbing, and so I tend to shy away from this rolling my own. One of the things that came out of this talk, which is this experience, which is quite interesting for me, and I really wanted to share with you. So that was more architectural stuff. But the thing that often things people don't think about are data, and this sometimes irritates me. Like, guys, sometimes you really need to think about your data. In this particular case, relational databases weren't the solution. I mean, you can solve this problem in a relational database, but it's not optimal, and it's not the greatest for highly connected databases. So sometimes you need to look at the data, have a look to see what you're trying to solve, and maybe the database technology that you've got at hand is not the right database technology. If you're doing a scalable distributed system, then always consider the shard points. Think about what you're going to use to be able to break the system up so that I can move data out into separate elements. In our particular case, we did verification type and entity type and by customer on those different nodes. But we could equally have done that for putting that data into different databases. But think about that in the early parts of your system, to think about those shard points, because they're very difficult to start bringing in later on as you progress with your system. One of the other things that we should consider is how data ages. So one of the things that frustrated me when looking at the system is that people weren't looking at how the data in the system ages. And I'll give you an example of this. I need to verify your driver's license to say, have you got a valid driver's license? How long does it take for a driver's license to expire? 5 years. Why would I want to check every month for the next 5 years whether your driver's license has expired? So often, people just going, well, driver's license, and we're actually going to work on it. Well, that's not the solution to the problem. Is just look carefully at your data, look carefully at how your data ages. Sometimes, for example, in the solution that we were looking at, is property data doesn't age as quickly as financial data ages. And so you want to be able to look very carefully at how you pull your data and where you pull your data from, and how fresh you maintain your data, because sometimes you don't need to maintain it as crisp and fresh as you think you need to, or you don't need to run that process as often as you need to. You could run that verify driver's license every 3 months just to catch endorsements, for example. Yeah? So this is something that people probably need to consider. One of the other things that we like to start doing in our systems is to break our data into smaller data points. This allows us to create raw events. And we're going to talk about why raw events are actually quite important when we start looking at how data needs to be projected and how how we can solve certain problems by using a projected data. But we often bring the data into the smallest data point, save all of that data so that we can rebuild the version of the truth off those events. And another thing that you would want to consider in this particular solution is trying to bring the data closer to you. If you noticed in some of those endpoints, they were pulling data, going off to a remote endpoint and getting data from another data supplier. Well, why don't we consider an active service pattern? Why don't we consider that this might be the supplier out on the web, and we can process all our data locally by keeping a local version of what the supplier has, keep a copy of what's out on the web at the local point. All right, so we can pull the data using this data pull element into our system, and this system still thinks that the data is as clean and fresh as it needs to be. And all we're doing is pulling this thing batch individually overnight into our system so that we can process the data closer. So we're bringing the wait time down. All right, but we hit a burning point. As we were processing, what we found is that data set that we were talking about, we managed to get down to be processed in about 3.5 days. All right, so we've gone down from 3 months to about 3.5 days by applying this architecture. But we had a problem. At this particular point, we were frickin' flying. We had messages up the wazoo. They were flying backwards and forwards and going through the system. But at this particular point, we had a problem. The slow point was our database. So the slow point was trying to figure out what alerts we needed to be able to raise. And the way we solved this was to create projected data and say, this is what the data currently looks like, this is what a guy's profile looks like now, and save that away. And at some point, look to see what the data looked like when it came back from our processing, and then compare those to find out where we were, where the system was. And we used this pattern, this projection pattern, in a previous system, and I really just wanted to talk about this particular architecture, which is the aggregated reporting pattern. And it's basically trying to get data in a system to be reported. The problem statement is, I have two systems. System 1, which is a website, and System 2, which is a website plus an API. They do very similar things, but I need to report as a consolidated system over both of those systems. How would I solve this problem? And the problem we reach for is this aggregated reporting pattern, where each one of these systems was using a central processing engine to do whatever it needed to do. This processing engine would raise the events, and the events would then be projected into this reporting database, completely denormalized data, into the view that we actually needed. We used that same pattern where we had the burning points to create this view of what we actually needed to look for. In order to apply this, we need to break our data into small raw data sets, which are events. We need to log all the raw data. We need to create projections off those raw data sets. And those projections might be duplicated, a single projection for a single purpose. All right? and we create a single projection per view or report. And this, if you think about it, is really that query side of the CQRS pattern. So the final solution, and I'm going to speed up a little bit because I've gone over time, this thing's telling me way over time. The final solution was processing servers here with the parallel processing, Neo4j graph database to do this highly connected database, transactional application data, so this was for logging in and making sure that we did stuff that really didn't belong in Neo. We had supplementary projected data, so as we had done some of this, like what does the profile look like now, we were projecting it in here, and projected data for a large number of our alerts. And this was the final solution. As you can see, a polyglot system with large amounts of data spread out to different systems and the parallel processing on distributed buses. So points to remember, reactive systems help us to scale, so this react response over the request response to decouple our systems. Transactions are your friends. I'm not going to harp on it. Think about your data, find the suitable shard points, denormalize the projected data to save some of our processing time, active services to reduce the wait time. Always consider alternative technologies. Don't just look at the home base and say, I'm doing SQL and I'm happy with SQL. Let's have a look at open source technology. Polyglot databases can work. We've shown it. It works all the time. Any project that I'm working on now, I normally have 1 or 2 different types of technology database technology that we'd be working on. And we simplify the endpoints. If we simplify the endpoints, it's easier to scale. We can move those hosts all over the place onto different machines. It provides testable endpoints and simplifies the performance testing because I'm able to just focus on one particular element. I don't have to worry about coordinating everything. All right, so why was this slide in here? So this was a DevCon slide, and it was a cheeky little slide. Basically, we were able to market anything. I didn't want to market myself. I didn't want to market my company. I actually wanted to market where I came from. Now, you Durban people, this is probably going to go out onto the internet, so hence I want to be able to talk about it. Consider Durban. Consider coming to work in Durban. All right, we have some amazing companies. We have SA Home Loans. We have Derivco. We have Mr. Price. We have Code. We have a large number of companies that are working with some really interesting tech. Durban is considered this New York Times 7th best place of the 52 places to visit in 2015. Go and have a look. Check it out. We've got an awesome beachfront, we've got awesome lifestyle, we've got weather that's pretty decent all the year round, and the other little cheeky stab is that this is unlike Joburg traffic. So that was the week before DevConf, driving to work, I took this photograph. You'll notice there are no brake lights, there's no red there, people are all happily traveling along, and that's at 7:38 in the morning, so that you could see that that was actually what actually happened. So consider Durban. All right, that's the talk, guys. Thanks very much for listening. It was great to be here.